While brushing teeth in the morning, the white toothpaste foam turns light pink. Oh, the gums are bleeding again. How does blood circulate within the body? Today we will learn about the heart's pumping function and follow a red blood cell on a special operations journey. Let us first review anatomical knowledge. The primary function of the heart is to pump blood, driving blood flow throughout the body through its rhythmic contractions and relaxations. The heart has 4 chambers: the left atrium, left ventricle, right atrium, and right ventricle. The atrioventricular valve between the left atrium and left ventricle is called the mitral valve, and the one between the right atrium and right ventricle is called the tricuspid valve. Fresh from their journey through the lungs, the oxygen-rich red blood cells, fully energized, continue their special ops mission within the bloodstream. The red blood cells enter the left ventricle from the left atrium, where they first experience the isovolumetric contraction period, the interval from the closure of the atrioventricular valves to the opening of the aortic valve, lasting 5 seconds. During this period, the ventricle contracts, but its volume remains unchanged. Interventricular pressure rises, exceeding atrial pressure but remaining below aortic pressure, while both the atrioventricular and aortic valves are closed. As the ventricle continues to contract forcefully, interventricular pressure rises further. When it exceeds the aortic blood pressure, the pressure difference forces the aortic valve open, and blood is rapidly ejected into the aorta. This is the rapid ejection phase, lasting about 0.1 seconds, accounting for approximately 70% of the stroke volume during systole. Following rapid ejection, the ventricular volume decreases and pressure drops, while the aortic volume increases and pressure rises. At this point, blood in the ventricle, propelled by the kinetic energy from ventricular contraction, continues to enter the aorta more slowly until ejection ends. This is known as the reduced ejection phase, lasting about 0.15 seconds, accounting for approximately 30% of the stroke volume during systole. The red blood cells experience the isovolumetric contraction, rapid ejection, and reduced ejection phases during left ventricular systole, lasting a total of 0.3 seconds. After entering the aorta, the red blood cells travel to organs and tissues throughout the body, delivering oxygen and removing carbon dioxide. This will be covered in the study of gas exchange in the blood. As one group of red blood cells departs from the left ventricle, the next group is eager to enter, anticipating the start of their journey. At this moment, the ventricle relaxes and interventricular pressure falls. When it drops below aortic pressure, blood in the aorta tends to flow back towards the ventricle, pushing the aortic valve closed. The ventricle is now a closed chamber. The ventricle continues to relax, and interventricular pressure continues to drop. When it falls below atrial pressure, the resulting pressure drop creates a suction effect, opening the atrioventricular valves. The period from the closure of the arterial valves to the opening of the atrioventricular valves is called the isovolumetric relaxation period. With the atrioventricular valves open, blood from the atria and pulmonary veins rapidly enters the ventricle due to the suction caused by the falling interventricular pressure. Ventricular volume increases rapidly and pressure rises quickly. This is the rapid filling phase, lasting about 0.11 seconds, during which approximately 2/3 of the total ventricular filling volume enters. As blood volume in the ventricle increases, the pressure difference between the atrium and ventricle decreases, slowing the rate of blood inflow into the ventricle. Ventricular volume increases slowly. This is the reduced filling phase, lasting about 0.22 seconds. In the final 0.1 seconds of ventricular diastole, the atria contract, forcing blood from the atria into the ventricle along the pressure gradient, allowing for further ventricular filling. The time taken for one complete cycle of contraction and relaxation of the atria or ventricles is called the cardiac cycle. The number of cardiac cycles per minute is called the heart rate. Assuming an average adult heart rate of 75 beats per minute, each cardiac cycle lasts an average of 0.8 seconds. Atrial contraction lasts 0.1 seconds, and atrial relaxation lasts 0.7 seconds. ventricular contraction lasts 0.3 seconds, and ventricular relaxation lasts 0.5 seconds. During the first 0.4 seconds of ventricular diastole, the atria are also relaxed. This period is called the period of complete cardiac diastole. The significance of the atrial and ventricular contraction periods being shorter than their relaxation periods within one cardiac cycle is 1.it allows the atria and ventricles adequate rest. 2.it allows the ventricles sufficient time for blood filling, ensuring the effectiveness of the next ejection. 3.it favors the blood supply to the left ventricle itself. When heart rate increases, the duration of the cardiac cycle shortens. Both systole and diastole are reduced, but diastole shortens proportionally more. Consider, when heart rate increases, the cardiac cycle shortens, with both contraction and relaxation phases shortening accordingly, but the relaxation phase shortens proportionally more. What impacts do you think this has on the body? Periodic ventricular ejection is of significant importance. 1. Ventricular contraction ejects blood, perfusing tissues and organs throughout the body, ensuring their normal functional activity. 2. During ventricular diastole, while the heart receives adequate blood filling, the myocardium itself also obtains sufficient rest and blood supply, maintaining its normal functional activity. After leaving the left ventricle and entering the aorta, the red blood cell continues its journey, traveling throughout the body with the blood flow.